This made me
Isn't it just...
Alright, kiddos, tomorrow is the test. You don't need a calculator because what's the one time you want it? When we're plugging in stuff for a definite integral. And the sad thing is, if that was the case, you could just plug the whole definite integral in and just bypass the entire process. So, no but you do, I would say still come early tomorrow. Let's plan on, you guys can get in at 7:45, start at 7:50. I mean, just in case you need the extra time, you might not. But you might, so that might be a good idea. When you come in tomorrow, we're going to turn homework spirals back in at the TA desk, and we're going to turn notes up at the front.
4 and 2.
Anything else? There's no extra practice test to turn in.
Of course, I work out.
Guys, make sure your table of contents are big. I don't want to take off any points.
Well, you plug the -1.
Just saying.
And then it'll be x squared.
Okay.
It's 2x.
I can give you guys like all this time to work on it in your groups, but if you're okay, I'm just going to let you look at it for a couple minutes to start, and then I'm just going to go through it with you. Is that okay? Yeah. Tomorrow you're going to have to work on it on your own. Today, this afternoon, tonight. I should be here for at least a little while after school. So please feel free, come in, do some problems with me. If you know you have a certain weakness that you tend to, like, archery, the nasty ones I'm just really bad at, or use subs, I can give you a couple on the whiteboard and have you try. But right now, let's just make sure that we get through these problems. Is that okay? Okay. As you guys look at this, why wouldn't we? Because on the test tomorrow, there might be some where we would. Why wouldn't we make u equal to 8 plus 2x minus x squared, aiming towards...
Nothing's going to cancel.
Okay, yeah. Aiming towards making this u to the -1/2 power rule. Okay, that's what we're aiming towards when we do this. Why wouldn't I? Tyler already said nothing's going to cancel. What he means by that is, stink kiddos. Do you see how I'm going to have du over 2 minus 2x and there's nothing there? There's nothing to cancel. We went to the boards yesterday, remember? And if you could cancel, that's great. But if you can't, what do we think?
Let's go at it for that complete square.
Arc sine.
You're going to have to complete this.
If we can't think u to the -1/2 because nothing's going to cancel and it's just going to get worse as we try to do integration on craft, think arc sine. Not arc tangent because there's a square root. Not arc secant because there's nothing in front. Does that make sense with the forever cards?
Yeah.
So arc sine. For arc sine, I really, really, really want this eventually to be the integral of 1 over a squared minus u squared, right? So does it make sense that I'm going to go ahead and rewrite this to be the integral of dx over square root 8 minus x squared minus 2x? Does that make sense why I'm doing it?
Root 8. And also complete this one.
Because the 8 might have something to do with the a squared. And for the u squared, well, I want that x squared first whenever I'm factoring quadratics. I pulled out a negative because there was a nasty minus. It's looking really good, except I need to complete the square. So, and what I do in one place, I have to offset somewhere else, right?
Yeah.
Okay. Complete the square. Divide, cut in half, 1, and then square. Why am I putting a +1 +1?
Because you've got -1.
It's a -1. And I need to offset it. Remember, adding by 0 creatively. I need to offset it by the opposite. So now I can go ahead and say, this is going to end up being... Don't I have 8 plus 1? The a is nicer than we thought it was. And then when we factor, guys, what is going to be squared underneath?
X minus 1.
That's square root x minus 1. Now we can go ahead and compare to what we wanted and say, all right, it's time for u sub. Who's your a?
3.
Who's your u?
X minus 1.
Who's your du?
1 dx.
1 dx. So now say, okay, if I know my arc sine formula, arc sine. 1 over 8? No, that's not arc sine. What is that? Arc tangent or arc secant, right? Pause. It's a multiple choice answer. Do you even have to stress? Forget that. There was only one arc sine. But does it make sense? arc sine of u over a, because I could go ahead and substitute a squared minus u squared. The du goes in the dx spot. There's no extra constant. I'm done. Yeah.
On the AP, if you got something like that, would you just look and see if it's not u sub, it's arc sine, so just choose the arc sine one?
Hopefully, but couldn't there be like a 1/2 and be none of these? So just be none. Because if it was something like 2x minus 1, there'd be a 2, so there'd be a 1/2, and that would be wrong. But if you have like 50 seconds left and you have to make an educated guess, not 50, you could do quite a bit in 50 seconds. 10 seconds left. Questions, are we okay? P.S. Hey, look. It's all nice and worked out also on the notes, but we're working it out too. We're working it out too. We worked a lot together yesterday, so I'm not having you guys do it apart.
That's secret.
Why is it arc secant?
Because we have that 2x on the outside, we're looking at it.
It's just a constant. I have somebody on the outside and stuff on the inside. It looks good to me. But is it going to help kiddos to think of your rules tomorrow and say, I wonder if this fits 1 over u squared minus a squared du? Yeah, we're aiming towards something. Listen. When we're aiming towards something, we look at it and say, now, pause. Can I give you a word of advice? When you're looking for u with arc secant, don't look here. Because this is outside the square root. Something could have simplified, something could have changed it. And this one is a super, super nice problem. You guys had one in homework, I think. That was a little off. There was an x here, not a 2x, and people got really confused. Look here and say this is under the square root. It's trapped. That has to be u squared. If that's u squared, who would u need to be? Now, you guys, this is a nice one. The 2x is right there chilling, and you could have also found it from outside. My hint is look on the inside, just in case there was some constant that messed that guy up. A is equal to just 1, right? Du is equal to, not, sorry. I went ahead in my head. Du is equal to 2 dx, right? So dx is equal to,
du over 2.
you guys okay?
Yep, that's why he's getting
So when you say don't look at the u on the outside, is it because there might be some a constant we take out?
Kind of. For instance, this could be a 3, and it's still totally this problem. Even though the 3x doesn't match the 2x, it's okay because eventually I'm going to pull that 3 out and I'm going to get the 2 in and it'll work. So just in case this isn't perfect because there's some extra constant messing it up, I can always count on this being a u squared so I can square root it. Does that kind of make sense? Okay. So when I go to figure everything out in my substitution, you need to go ahead and say, all right, 1 over. This one, there is just a nice little u there, so I can put them in. I can put in my du over 2. But can I pause for a second? Can I go back to what if this was a 3? Is that okay? What if this was a 3? Question, would I be able to put a u?
No.
But I need a u for my formula.
So let's solve for u.
So what I would do exactly is I would pull out the 1/3 and say whatever. And I would say there's an x left over. I'd come up and say, you know what, no big deal. I can say x is equal to u over. Does that make sense? I could do my little integration on crack. I would get the u in there and an extra constant I'd have to deal with. So that's why I'm saying don't just assume whatever's outside is your u, because you might have to do a little integration on crack to make it the u. Okay, this one's nice though. It was just u times the square root of it. But I have an extra 1/2, right? If you hadn't done this carefully, you might not realize the answer should be 1/2, times
1 over
1 over a. Oh, this could have been so much nastier. 1/2 times 1 over a times arc secant of u, who is 2x over a. Now, I'm really glad that we had this problem because, question, what is so different in their answers than in my answer? Absolute values. Now, pause. First off, this is totally the correct answer. So then, second off, it's like, stink. Well, hold on. Wait a minute. No. Our forever cards. We said for arc secant u over a. I'm not gonna mark anything off today, but we need to change that forever card because I totally forgot to put an absolute value. And I'm so sorry.
No,
Is
just for
it
every,
for-
is
So-
it for more than secant?
Just for secant. Steak, this is gonna be back a ways.
Just tell us now, and don't go left.
I'm here, it's right here. I need you guys to see that I'm making it official. I don't know why, actually I do know why. We fixed it one year and I didn't fix it in my master copy that I reused, so. It's absolute value of U only for the secant.
That's weird.
Well, cosine's funny in that in the first and fourth quadrant, which is the normal inverse for arcsine, arctangent, arccosine is the same, that's kind of what's going on. But arctangent I don't have to worry about, arcsine I don't have to worry about, but arcsecant comes from arc, cosine, which has a different domain. Anyway, just right here, absolute value. But wait a minute, when we did the arcsecant formula, wasn't absolute value of U the derivative?
You mean what?
The derivative of arcsecant, wasn't it 1 over the absolute value of U times the square root of U squared minus 1? Never mind. I don't know if you guys remember. Pause. Shh. Look at me. Okay, for arcsecant's derivative, I'm pretty sure there was an absolute value in it. There needs to be an absolute value in his integral too. Does that kind of make sense?
Yeah.
Let's not stress about him too much. Besides, you guys, when you see, or if you see absolute value tomorrow, you don't have to be like, it's wrong. No, it's actually right. Whoops. Anyway, all right, here we go. Big question, idea number 2, done. Number 3.
Oh, this one does not work out.
Ooh, there's an X on top. Yay! Let's set the
No,
whole
it's a
denominator
slash.
equal to U. U equals 36 plus X to the 4th.
Yes, there's an
D
absolute
U.
value of secant.
Yeah, there it is. Thank you.
Yeah, no, it's absolute value of X times, or 1 over
Yeah.
absolute value of X times.
So that's how we do it.
I still don't like that though.
Why is this bad?
Because it's only one RCM.
Well, you're still-
I only have 1 and I really want 3.
Oh, can we?
Look at the answers! Look at the answers! The multiple choice sometimes give you all you need. They're not going to LN. Yep. They're not going to LN. They're hinting, now there could be an LN in here, but they're hinting at, hey, this is inverse trig. And inverse trig, what's the only one without a square root?
Tangent.
Arctangent. So I'm aiming for, right? I'm aiming
B
for
or
1
C.
over U squared plus A squared du. Well, he's my variable guy. He's somebody squared. So who is he squared of?
X squared.
X squared. Is that okay?
Yeah.
Now go carefully. Du is equal to
2X.
2x dx. Dx is equal to. So when I go to plug in, the x cancels, but I have something extra, don't I? Who's my extra guy? 1/2, not 2, right? It's 2 in the denominator. So we have 1/2 times 1 over a, right? This is an arctan. 1 over a times arctan or tangent inverse, same thing, of u. Who is it?
It's B.
But do you see how the 1/6 was just waiting for you to mess up and mess up your
Yeah.
usage?
They were gonna prank you.
Yeah. Are we okay?
Yeah.
Alright, this one.
Is it a simple arctan, yes or no?
Oh wait, well, I mean, no,
It's
it's not.
not a
I'm not
simple
saying
arctan because we
so.
have this guy up top, 5x over, that doesn't look like arctan.
So depending on the x is in the numerator, is that how we decide?
Yeah, except to look like, guys, can I go back a second?
Yeah.
This one had an x in the numerator, but why did I still go arctan?
Because
It wasn't
canceled out.
enough.
Oh,
If I chose this to be u, I need 4x cubed, I need x cubed up here. I only had an x, it wasn't enough to do like ln of u, or sorry, 1 over u. So then I had to look and think arctangent, and then, oh, arctangent, u would be x squared. The x comes from this u. So basically, long story short, if you have enough variables in the numerator for the du of the entire denominator, go for it. Just make the whole thing u. If you don't have enough x's, it's almost always going to be arctangent. And that's specifically when you have stuff in the bottom. You can have stuff in the top, like integration on crack examples, where it's like, oh, there's a little extra x right here just chilling. It's like, oh, no big deal, I'll go find him and I'll go plug him in and we'll keep solving. But this, when I have all this mess in the denominator, I would, for this guy, if I had done it the other way with the whole thing being u, I didn't actually show it, but check it out. I'll cancel 1, but all of a sudden, I have all this yucky x stuff in the denominator. I don't want that. That's awful.
Can you actually,
Arctangent. It's not really something. But in the example we were just looking at, Tyler, sorry, can you actually, no, it's not going away. Oops, this guy. This guy. What if I set u to be the whole guy? Because I see this x guy, and he's only 1 degree less. So if u was x squared plus 9, what would du be? Oh look, this x is good. It's x to the first power. I have an x to the first power. It's great, except...
We separate those.
So if I was to go ahead and plug in, I don't mind the 5x. He's great if I plug in this u. The problem is, kiddos, is this my entire problem? And the answer is no. I don't mind him. Who do I mind? I have to solve these separately. The 5x is going to be great if I make the entire bottom u, because this x will cancel. The problem is, he's great, he's not. So I separate. Hart method, 5x goes over x squared plus 9, and 16 goes over x squared plus 9. This one is going to end up being an ln, I have 1 over u. This one's going to need to be no square root. Who is he? Arctangent.
You see, if we separate, like, we don't need, like, what I do is, for the first one, 5x over x squared plus 9, I use the same method as the last question, like we cancel the 2x, dx equals du over 2x, so we can cancel the x, then we can solve for the tangent.
No, not tangent. ln.
No, because if you use Hart method, you separate that, you get 5x over x squared plus 9, and then you say u equals x squared plus 9, you can...
Okay, I hear you, but the problem is, I can't solve this. I need u's. See what I mean? It's illegal. Yeah, it's illegal. So remember, x squared plus 9, I am going to cancel the x's, but I can't solve the integral until I have a function in terms of u's now that it's u's. It's a good idea, but...
So you didn't put u on 16 or 16?
Well, see, I could put u, but the problem is I'd have u and du over 2x. I have an extra x in the denominator. I don't want that. Does that make sense? So that's why I'm going to totally separate and say, well, this was great for that guy. For this guy, I'm going arctan the whole way. And some of you guys are like, you already used u. Okay, fine, I'll use v, whatever. V is equal to x, dv is equal to dx. So I can rewrite this guy to be 16, 1 over v squared plus a squared dv. This is only if you're like, wait, you're not allowed to use u, you already used it. Okay, fine, I'll call them a different letter. But I'm still doing the same process. That's arctangent all the way. And over here, I'm going to have 5 halves times the integral of 1 over u du. This way also helps you distinguish who is u and who is v. It's like, oh, I'm doing 2 different things here. So I'm solving one problem, but I'm solving the separate integrals 2 different ways. This way, how do I, ooh, this was on the, one of the things I didn't know if first was, isn't this 5 halves ln?
Wait, so wait.
This will be 16 times 1
We have to what's the... It's not coming out.
What's your homework file?
Homework file, but
And notes.
the homework tonight is
The review. Yeah, the review that you were supposed to start last night, keep going tonight. I'm so sorry I didn't go over questions. I'm here during lunch. Nothing weird going on today. I'm here during period 7. I'm here after school. Sound good?
I always forget to do the use of.
I actually wanted to read this sideline.
Hi, everybody. We were doing this one before we started on the big ideas.
Oh, wait, Misty, was the other one pi over